Okay, let's look at example 6. To calculate the height of a building, Kevin measures the angle of elevation to the top as 52 degrees. He then walks 20 meters closer to the building and measures the angle of elevation as 60 degrees. How high is the building? So let's first draw a diagram. Grabbing your beautiful and trusty straight edge to your ruler, let's draw the ground, straight lines, and let's draw the building, straight lines, beautiful straight lines, and let's connect the ground to the building because that will become our angle of elevation, the first one anyway, because Kevin initially looks at the angle of elevation as 52 degrees. So if we label this initial point A, then A to the top of the building, the initial angle of elevation is 52 degrees. Kevin then walks 20 meters closer to the building and then measured a steeper angle of elevation. So to the same pointy part, the top part of the building, but 20 meters closer. So let's call this point now point B because he's now closer. This is 60 degrees. You're looking up angle of elevation. Now we know the distance from A to B. That distance there is 20 meters because Kevin walked 20 meters closer, right? So this we know, this corner angle is got to be 90 degrees because it's assuming the building's upright is perpendicular to the floor. We don't really want a leaning tower. Let's label this angle C, and then the top of the building, let's label angle D. So what is it that we want to find? We would like to find the height of the building. So if we call this H, the height of the building, so that's going there. So define our variables. So let H equal height of building, brackets in meters because everything else is measured in meters. Right, so the question is, how can we find H, the height of the building? Well, if you look at H, the height of the building, it's related to the 60, well, there's this right angle triangle, which gives us hope that we can use SOHCAHTOA because right angle triangles makes life easier. Not Pythagoras though, because we don't have to other side lengths, but we do have a 60 degrees, and that is opposite the height of the building. So if we could either work out what the distance BC was or what BD was, we could easily apply SOHCAHTOA. Well, if we could find BD, well, how could we find BD given our knowledge of the 52 degrees and 20 meters? Well, 52 degrees is opposite that BD length, so that's giving us hope to work out the sine rule. So what else do we need to know to use the sine rule to work out BD? Well, we also need another set of opposite angles and sine. So if we know what the 20 meters, if we can know what the corresponding angle, the angle opposite that blue side is, then we're good to go with the sine rule, right? So what's the angle opposite that? Well, it's that blue angle because that's the corresponding side of 20 meters. Well, if we can work out what that is, then we can go ahead to use a sine rule to then work out the yellow BD, which then allows us to use the sine rule, like a SOHCAHTOA sine rule, because we have the opposite and the hypotenuse side. Well, how do we then work out that blue angle over there? Well, we know this is 52, and well, if we could work out what this purple angle is, then we could easily work out what the blue angle is because sum of our angles in a triangle is 180 degrees. Well, it's all good because this is on a straight line. So angles on a straight line add up to 180 degrees because of supplementary angles, right? So we can easily write that angle ABD, which is the purple angle. Oh, let me rub off the irrelevant one, not 50. Ooh, that was bad. Not the 52 degrees one, but the angle ABD is 180 degrees minus 60 degrees. Why? Because of supplementary angles. angles that lie on a straight line. So in other words, that's 120 degrees. Do not forget your degree symbol, otherwise it's assumed radians, and that's not good. Because we know the purple angle, then we can go, well, yellow angle, 52 degrees, plus the 120 degrees, the purple angle, and the blue angle must be 180 degrees, because sum of angles in a triangle is 180. So we can write angle ADB, because that's the blue angle, is 180, take 120, take 52. Why? Because sum of angles in a triangle is 180 degrees, which is 8, using a calculator. So now that we've got the blue angle, so we can apply the sine rule, then we can easily work out what the length of BD is. So I'm just going to do it up here. So using sine rule, so tell your reader what rule you're going to use, because we have so many rules. Using sine rule, default formula, A on sine of angle A equals B on sine of angle B, capital B for angles, lowercase b for sine length. Let's substitute it. It really doesn't matter which one's A, which one's B. So sine length, we know of 20 is corresponding to angle of 8 degrees, because that's the blue side and the blue angle. And the side of interest, BD, has a corresponding angle of 52 degrees, because that's opposite to each other. So we can cross multiply, or we can just rearrange. So BD is 20 on sine of 8 degrees multiplied by sine of 52, because sine of 52 is on the bottom. I want to do the opposite, get rid of it. So multiplying it. So using a calculator, BD is approximately 113.24 meters. Now don't forget, make sure your calculator's on degrees, because right now our question's in degrees. Make sure it's not on radians, otherwise you'll get the wrong answer. So BD is 113.24 approximately. Now, as we said, looking at the angle BCD, because that is a right angle triangle, we can apply SOHCAHTOA. So we've got the opposite side and we've got the hypotenuse BD, so that screams sine or SOH to us. So default formula, sine of angle is opposite over hypotenuse. In other words, sine of 60 is opposite, which is h, divided by hypotenuse, which is BD. In other words, sine of 60 is root 3 on 2 is h divided by 113.24. So h is 113.24 lots of root 3 on 2. So using a calculator, that's approximately 98.07. So what was the question again? How high is the building? Well, it's approximately 98 meters tall. So make sure you round your answer appropriately. Leaving to 2 decimal places is probably not the best choice in this case. So they gave us numbers as whole numbers, so we should, as a general rule of thumb, round to what they give us, which is whole numbers. So sentence conclusion, therefore the building is approximately 98 meters tall.